Good evening, everybody. So let us start our lecture tonight, and today is August 19, right?
Yes.
Okay, so this will be second lecture, or it will be still introduction and in syllabus discussion. Okay, so just few. Let me recap our last lecture quickly. Okay, so this is our D2L. So all announcements will come through D2L. Okay, so please check D2L. So when I send an email, when I send an announcement in email, announcement in D2L, do you receive an email? Okay, then that's good. Okay, and how about it says when I make some update, and this is major edits, send a notification and restore it for those who dismissed it, or something like this. You get this, right? Okay, so today I created a team, MS Teams team. Okay, this group. So we will use that for quick and short conversation. Sometime if you may have an issue, then other people may help you. Okay, send that. So you know how to use MS Team, right? So but only the public thing. So you know how to use it for public and private. So only you use it for public purpose. Okay, and sometime I will send you some announcement over here in case I'm running late or something, facing some issue. Okay, I will send a quick note over here. Or so we will use this link in case I cannot come in face-to-face class. It may not happen, but it may happen 1 or 2 month or sometime. So then we will use this link for. I will do this class online, but using Teams. Okay, so then you will join this when we will do. Okay, one more thing is that, and please, you will see that I will use this almost in all my communication, all my notification. I send this every semester, but still some students do not follow this. Still I got a few emails, 2 or 3 emails from some students. They did not mention that section name. It's really difficult for me to find out your section, and then sometime I can guess, sometime I cannot guess. So it will take you for few seconds. Please help me by mentioning your say AA algorithm analysis. That's AA03 S03, your section algorithm analysis section 03. I will understand. Okay, so let me recap the course. This is for 3 2 this is also something. 3 will be something. Okay, for the syllabus, let me quick review for the syllabus. Is there anyone here who was not present in the last lecture? You are new here. Okay, so for you and for all everybody, I created a YouTube playlist. I have a YouTube channel. I created a playlist. I uploaded the first video. It will come up here soon. So in case you miss any lecture, please watch it here. Okay, and at your earliest convenient time before you come to next lecture. Okay, so that you do not miss anything important. Okay, so this video is processing. It should be ready. Okay, and I'm parallelly teaching another section for this course. That is section 2, and your section is section 3. Okay. Is Nick here? Nicholas? Someone? Okay. Maybe he's trying to join online. this is face-to-face class. Unless needed, I will not broadcast this. Okay. Okay. So this is the syllabus, and this is my office hour. Hopefully, I will get my office from next week. Okay. And especially, please follow my communication policy. Do not send me email from D12. Okay, and do not forget to mention your course name and section. One more thing is that you will need a webcam. We are not sure yet. We may have paper-based test or computer-based test. In case it is computer-based test will be here, but you may need to use your webcam. We will discuss this later. Okay. And this is the learning outcome, right? So then we will learn at the end of the semester. We will learn this, especially what will be in one sentence. We can say what we learn. We will learn how to analyze an algorithm. Then, if we know that how to analyze an algorithm, then we will be able to develop good algorithms, efficient algorithm. Whenever we develop an algorithm, then we will be able to judge ourselves that whether it is a good or bad. So I will go through with some examples today, and last lecture I went through some, and I will go some. Okay, and I got some suggestion. I may change a little bit over here our course requirement. So this is the face-to-face class. So I got suggestion from department chair that or senior professor there should have a attendance point. So I may borrow some maybe 5% point from assignment or quiz, and assign that for assignment for what is that called, attendance. If I do that, then I will keep attendance. Okay. Okay. And another thing that maybe I need to update over here. So the missing test policy. So it is okay that test 1, if you miss test 1 and test 2, then your final exam will compensate that with 20% penalty. But I was thinking, if you miss final exam, that how it would be covered. So I thought that I would consider test 1 and test 2 with 20% penalty. But someone suggested me that there is a valid reason that test 1 and test 2 will not be cumulative. This one is chapter specific. Okay, so for final it will be cumulative. So in case you miss final, then I should consider everything for your assignment and quizzes. So test 1, test 2, all tests and assignments and quizzes and attendance I will consider. Okay, so I will rewrite this sentence, last one, and I will upload this by this weekend. Okay. And I discussed that, as I told you, that our please maintain academic integrity, and the university is very strict about this. So especially when you do an assignment, okay, please do it yourself. Even if you do some mistakes, do the mistake. Okay, if you cannot complete it, do as much as you can. Okay, but do not copy from somewhere. If you copy from someone, your friend or something, then both of you will get penalized. Okay, so rather do it yourself. So, but I like that you will do collaborative study. You have a group, and then study in a group. Okay, study in a group in a way that you help each other. Sometimes when you study, right, sometimes you figure out a good technique how to remember this, right? Share your technique with your friend, and then you will see that your friend will know another technique, right? And get that technique, learn that technique from him or her. In that way, learn collaboratively. Okay, but do not copy and paste something. Okay, this, he is trying to join someone. No. This is gone. Okay, the last thing is that this is the it's all about my YouTube channel. Okay, so this schedule is tentative. Okay, we may change this or make some updates. Okay, this is not finalized yet, but pretty final. Okay. Okay, so in our last lecture we were discussing this analysis and basics of algorithm, right? So only one person you were absent in last lecture. Okay, so please watch my previous lecture video and I will do a quick recap though. Okay. So in our last lecture we learned that two elements, data structures and algorithms, they work combined jointly, right? In order to write an efficient algorithm, efficient program, you need to consider two things. One is data structure. Your data needs to be structured, is put organized in a good structure as needed, and then your algorithm needs to be efficient. Okay, so if you have a good data structure, you are half done, and then your next part will be writing a good algorithm. Okay, so if you go for an interview, you will say that sometimes they will ask you to write an algorithm and they will ask you, okay, analyze your algorithm, what is the efficiency of this algorithm. Okay, sometimes people may ask you, okay, write an algorithm that is linear time, okay, or logarithmic time, and then exponential. We will learn this. Okay, or constant time, that takes constant time. We will learn this today. Okay, so here in our last lecture we discussed this, right? We discussed this is a part of an algorithm. Okay, we analyze this, how we analyze what is the efficiency of this algorithm, what is the running time of this algorithm, right? How much time it takes to complete this process or this algorithm in terms of n is the size, right? So this t is a function of time that with respect to n is the independent variable, always say. We don't know yet n. So here there is only one term. This executes how many times? N squared times, right? So this is the inner for loop. It executes n time, and then there is outer for loop. It executes n times. So n times n equal to n squared. So this part is n squared, and there is 5 statements here, and then all of this executes n times. So 5n, total 5n, and there are, here we consider that there are 25 statements over here, and each of these executes only one time, so then 25 here. So we consider that, or we can consider that, let us think that each of these takes 1 millisecond to be executed, maybe 1 millisecond or microsecond, that doesn't matter. Okay, so then this 25 statement will take 25 unit of time, millisecond, and then this will take 5n unit of time, right? And this will take n square unit of time. So we learn that for the values, for the value of n equal to 2, 3 and 4, right? So this part is dominant. So this part will take more time if we have smaller n size, like if n equal to 2 or 3 or 4, right? This part will be dominant. And for 5, this part and this part, all of these will take same amount of time, right? So if n equal to 5, then 25, 25, 25, all this part will take same amount of time for n equal to 5. But in case of n greater or equal to 6, apparently for a large n, so this part will be dominant, right? This part will take more time, n squared. Okay, so in the worst case, we say the worst case, we will learn that later, next lecture, that is called big O n. It denotes the the complexity of this algorithm or efficiency of this algorithm in the worst case. Worst case means for large n, for here it will take n square time. That was what up to what we discussed in our last lecture, right? Has anyone any question? Okay, so we went through a little bit more. For instance, if there is one more statement, some statement inside this first for loop but outside this second for loop, we discussed this in our last lecture, so please go through there. Maybe if starting from here we will go more in depth. For instance, now let us see another example. Think about like this something. Okay, let us think that we are given a problem to write an algorithm. So our problem is very simple, like to sum up 1, 2, plus 3, plus 4, plus 5, up to n numbers. Okay, so we want to find what is this value, right? So as we know that there are maybe multiple ways to solve this problem, right? So one of the naive way is just if for any n, it may be n, maybe 100,000 or whatever n value, we will do like something this 1 plus 2 plus 3 plus 4 plus 5 up to n, right? And then we, for the first way you can say s equal to 1 plus 2 plus 3 plus something plus up to n. We have to write down all. We cannot, in programming language we cannot give the order, right? We have to write maybe for 1000 or whatever value is, something like this. Okay, for s equal to, for maybe for n equal to 1000. Okay, then we will get a result, right? Okay, this is one way. Another way that if you know mathematics, then we know that it is if for s, this is a linear equation, right? So we know that in that case s will be n times n plus 1 divided by 2, right? Okay, we can give another parenthesis, no problem. This is formula 2, or you can say a for loop like something like this, like s equal to initially put x equal to 0. So these are the at least 3 ways we know that, right, to solve this problem. Okay, so if you write this way, right, so then what will be our, how much time it will take? But let us consider for this one, the easiest one. So what will be the time complexity for this one? Yes, it is constant time, right? Big O of n, it takes constant time. Constant time. No matter what is the value of n, it will take same time, right? There is no looping. There is only one statement. It may take constant, means 1 means is not 1 millisecond or 1 millisecond. It is a value, unit value. Okay. Then how about if I write my equation like this? What will be the time consecutivity?
N.
Yes, it is n. This is linear, right? How about this one? How about this one?
It's finite. Wouldn't it be 1 again? Wouldn't it be 1 again since it's finite? Isn't it, since it's finite, wouldn't it be 1?
We are considering, for instance, last value is 1000, but it may be a different value. So we say n, right? So n. So what will be here for this one? Okay. I'm not sure, but I guess, still I have doubt, but I guess that it will take big O of n squared time. Okay. The reason is, my guess is that, let me see, how does a computer or an electronic machine it works? Okay. So a computer or a calculator works this. So if you write this way, so this, they will add up these first two numbers, right? And then it will get 3. And then these 3 will be added with these 3. Then 3 plus 3 will be 6, right? And this 6 will be the next number with 4. So then 3 plus 3 equal to 6. Then 6 plus 4 equal to 10. And then this 10 will be added plus 5, right? Then 15, and so on. So it will take how many times? It will take more times, right? Then this expression. Then this expression. It may be logarithm, or it may be big O n squared, or it may be log n, log base 2. Yeah, I'll think about it. So what is it actually? But if you not, then let me know. Okay, but at least we know that there are multiple ways to write an algorithm, right? Okay, for some algorithms it will take constant time, and for same problem another algorithm may take linear time, and another algorithm may take logarithm or exponential time, right? So our goal will be developing an algorithm that is efficient, takes less time. So actually efficiency of an algorithm is measured two things: how much time it takes, and secondary thing is that how much memory it takes. What kind of memory space it takes, right? So nowadays memory space is we have a huge amount of memory, computer memory, right? Unless there is a big data, memory is not an issue. But timing is an issue. Okay, because a processor has continuously do many processing while it keeps the operating system on. Okay, so if we run a program and if it takes maybe 1 minute or 30 seconds or 50 seconds, then we will be, so if we run the program, start running, and it takes time to show its output, right? We will be bored, and sometimes we'll think, oh, our program is not good. So timing is really a factor. Okay, so this is the way that we will write algorithm. When we write algorithm, then we will be able to analyze it in terms of the statements. Okay, so So in today's lecture, so this week actually we are supposed to learn introduction and basics of algorithm, chapter 1 and 2. Okay, so that was the first part, chapter 1, and we discussed. Oh, by the way, I gave you a homework, right? What is the homework?
Read first 30 pages.
Yes, the homework. The first thing was to download the book, right? And I asked you to read the author names. Okay. So read the author names few times so that in case in an interview you are asked a question, what is the algorithm book that you studied? Okay. Then I asked you to read the chapters. How many chapters are there? About 35, right?
35, yeah.
Okay. And then I asked you to read just the title of the chapters. Maybe you will see that I thought some of these will be familiar to you, right? Some of the content will be familiar to you. Some are not, but we will learn something, but we will not learn everything. If you take a advanced algorithm course or algorithm course in masters, then you will read the same book, you will follow the same book, but we will cover in this course maybe 1/3 we will review data structure, and 1/3 we will learn, or half of the way we will learn something new. Okay, so then I asked you to read the first 30 pages, like these 2 chapters. Okay, if you did it, then thank you so much, and then if you did not have a chance, then I will give you a few more pages by this weekend. Just grab for a few minutes, may spend an hour, that will be fine. Okay, read some pages that you find interest in, and then go through these pages. Okay, so our chapter 2 actually in getting started, it says how in basics of algorithm analysis. Okay, it says so our basic, we discussed that what will be our basis of learning to developing efficient algorithm, that we start with some well-known or some existing algorithms. We will learn how to analyze those, and then from there we will learn how to write new algorithms and how to analyze our own new algorithms, right? So that 2 is part from chapter 2. Okay, so the 2 algorithms, well-known algorithms, okay, there are well known to everybody, the 2 sorting algorithms. One is insertion sort, another is merge sort. Okay, we are familiar with these 2 sorting algorithms, right? You use this from your like 1321, 1322, right? If you do, you are given a data, and if you are asked to write any sorting algorithm, you probably will write either insertion or insertion sort algorithm. That is the foundation of algorithm. So we know that an insertion sort algorithm takes, what is the time complexity of an insertion sort algorithm? So this is the code for an insertion sort algorithm. Okay, by looking this code, can you tell me what is the complexity or time efficiency of this algorithm in the worst case? Big O n. We will learn big O n, small n in our next lecture. For now, remember that big O n means that it takes time for the worst case. What will be the time complexity for this one?
N squared.
Okay, n squared. Has anyone any different opinion? Who said n squared? Okay, thank you. Does everybody agree, or anyone has a different opinion? Yes.
I would agree.
You agree? Yes, it is n squared. So actually the technique we learned that easy, that how do we find efficiency, then how many loop statement over here, right?
Yes.
So how many loops over here? 2 loops, right? One is for loop, another is do while loop. So this do while is inside for loop, right? So that means n times n squared. Okay, do you have any doubt in it? So everything is for loop is do while loop, right? So this is things maybe 1 time less than here, say n minus 1, j minus 1, but still n squared. Okay, so insertion sort algorithm takes n squared time. So if in case n become larger, then it will take more time. Okay, so this is the process of how to do insertion sort algorithm with intuitively with some actual data. You know that, right? How to do this, how the insertion sort algorithm works. People, when they play card, they put one after another sorting way with the insertion sort algorithm. Okay, these are the steps that it will take. Okay, so the running time, it depends on input size. If the already sorted, then it takes less time. Okay, so if it is completely unsorted or almost unsorted, then it will take more time. Okay, so but we say the running time is n squared. So now let us see. Okay, that chapter says here. Now let me go to the book. So chapter says it started with 2 basic algorithms, insertion sort, and there is another one, it is called merge sort. So let us go to chapter 2. So chapter 2. This is the insertion sort people use, right? So how do they sort this? Okay, like playing cards, they use this one. So this is the way how to put the this is the loop. So this is one for loop, and within for loop there is while loop. So n squared, n times n squared. Okay, so please read this topic a little bit one more time, so then you may find something new. Okay, this is the insertion sort algorithm. It takes n square. That discussion is this over here, but I'm going to another one. Okay, so there is another algorithm that we will consider it as our basic of developing good algorithm. So like our goal will be design a good algorithm. So later we will see that in a week, next week we will see that there is a formula. It's called master theorem. Master theorem, this formula is used to find the efficiency of running time of an algorithm. So master formula is used mainly for the algorithms that can be solved recursively using divide and conquer approach. So the title, it says divide and conquer. Divide means split the problem into some sub problems. Okay, some smaller instances, and then solve each of these, all of these sub problems recursively Okay, and then when these are solved, then combined the solution of all sub problems and unite them. Okay, so although the algorithm itself says divide and conquer, okay, but it has three major steps: divide, conquer, and combine. Okay, so the divide part, actually for all programs or all problems, we will divide the problems into smaller chunk of units, then we will solve each of them recursively. We know the recursive, recall the recursive method. Okay, in the recursive method we use same method, same formula, same code, right? But with every time we call this method with different input size, right? The input converges so that it goes to the ending point, that it stops recursive methods, right? Remember that recursive method you learn. So how long it will be divided? Until it comes in a smaller unit that can be easily solved. So the merge sort is a well-known example of divide and conquer method. Okay, so in the merge sort algorithm, what we do, we divide our problem. So for instance, data. Okay, we divide our given data. Okay, for instance, this is our given data. So he said we split it, maybe apparently halfway. We split it. The whole data set is A, and then we make it two pieces, the left side and right side. Okay, so then we got two pieces, left side and right side. Again, this left side and right side are splitted again and again. How long we'll split? Our goal is to make a sorted list, right? So for sorting, at some point we need to do a comparison, which one is better and which one is larger, right? And then maybe swapping, right? So we go in a small unit, and when we find the small unit, okay, two small unit like something like this and this, that easy to swap, right? Only two. We can easily say there is no loop statement needed here, only a comparison if is fine, right? Then we can do that. And then in the recursive method we solve this easily. Same in all this unit, we solve this unit, and then we finally merge the result. You see that this is when we are merging, we are using recursive, that 2 is coming first, and then 5, and then 4, and then 7, and then from here then 2, 4, 5, 7, this is coming merging, and then searching and merging together, right? So then how much time this type of algorithm it takes? There is a well-known formula, it is called master theorem. The master theorem is something like this. This is the standard version of master theorem. We will learn that later, okay, in chapter 4. For all recurrences of n, if n equal to is a smaller number, less than or equal to c, for instance, any constant number, then it takes constant time. But if it is not, if n is a larger number, then we will get this kind of formula: a times t of n by b plus dn plus cn. We will learn this, what this means. This part, a times of t of n by b, That means we are, for instance, let me come here. For the divide and conquer method, we are splitting our data set into half, right? Every time we are making it half. So this 2 is making half, 2. How many parts we are taking? 2, right? And how many parts, so how many such division are, how many the pieces? 2 pieces, right? So each take 2 this time, this amount of time, t of n by 2, and then this, so the total time will be 2 times of this, 2 times t of n by 2, and this plus theta, and theta n is the merging time for merging. Okay, and if it's n equal to 1, a small number, then it takes constant number, constant amount, but for a large n it takes this one. So we will discuss this in chapter 4. Then we will learn that this kind of algorithm, it will takes theta of n log n time. Okay, LG stand for log 2n. Okay, one thing that, let me write it down. For instance, if I have n equal to 1000, okay, so log, you say, if you type in log like this way, so that means log of n, it means log with natural with base 10 n. Okay, so you say log, that means base 10n equal to log 10 n equal to 1000, right? So equal to 1000 over here, 1000. To the power 3, right? 1000, that means equal to, it takes 3, right? 3 times log of 10, another log a equal to 1, so equal to 3. Okay, so then log means base 10, and then there is another log, it says ng log, only LG, that means n equal to, so log with base 2, okay, and then 1000. Do you know what, how much it will be result? Log is approximately log, I'm sorry, you can type in log, but if you need to guess it. Log 2 of 2 to the power is approximately 10, right? 2 to the power 10 equal to 1024, right? 2 to the power 10 equal to 1024. So then approximately it will come to 10, right? Close to 10. Okay, then how much if you say ln? Okay, this is natural log, log base e 2.7 or something, right? Log natural e means, and then 1000 equal to what? Do this calculation, okay, with the calculator or with the program. Okay, so you see that, so in computer science especially, we most of the time we use this ln, lg with base 2. right? So we deal with binary number, but in mathematics we use log with 10 base or ln with exponential base. Okay, so in your test or somewhere in the book, when you find something like you said LG or ln, be careful. Okay, the LG is log with base 2. Okay, and then ln is base e, and then if you say log, that means it is base 10. Okay, so the divide and conquer, using divide and conquer method. So actually the merge sort algorithm uses divide and conquer method. So then running time will be theta of n log n. Okay, LG, that means LG, that means base 2. Why it is base 2? Because it splits half, right? Every time it splits half, right? So base 2. Okay, so for other expression we will learn later that how to find the running time of an algorithm using this master formula. We will learn that later. Okay, the book we have different chapters. Has anyone any questions so far? Huh? What?
In the book, what page is it?
The page is, this is 36 maybe. 36. So here this page is different, right? It has some content page number is different, but this is the real page number. By the way, I asked you to collect a book, right? For the open book test, I said that the test policy is that for the open book test you are allowed to use any number of printed materials or hard copy of the book, but you will not be allowed to open any device, right? Electronic copy. And collecting this book is worthy. As long as you study, then you will need this book. Or maybe you can take a printout of this, but many pages, taking printout is will not be helpful. Buy the book, mark it, and then put some note, and then put it in your own way, organize it in your own way, so that you can find out some stuff quickly. And most of the quiz questions you will get from book. Okay, and the quiz question you will not get exactly, maybe some quiz question from the book, or it is a challenge for us. So whenever we teach this course for a long time, so every time we should make our own some quizzes that should be something challenging and different from other semesters. Okay, so that for instance, if you know the steps and know the process, understand the problem, then you should be able to find the answer. For instance, I'm looking at a quiz question for the divide and conquer process, right? So this one, which part uses recursion?
Oh, that'd be conquer.
Yes, divide and conquer, divide, conquer, and combine, right? Not all parts, only this part uses recursion, right? Okay, so if you understand this, then you'll be able to find this. Okay, okay, so when you read the book, please go through this example. See the, so our total number n, if each unit takes n time, c unit of time, then total time will be cn, right? And then in the divide and conquer method, we divide n by 2, splitting half, right? And then this n by 2 is splitting again half, so n by 2 divided by 2 equal to n by 4, right? And in this way we are splitting, we are counting in a small unit. Each of the small unit will take c amount of time, small amount of time, in constant amount of time, right? And then when you get constant amount of time, then you see that we get constant amount of time, then how many such iterations we do have? How many times it is looping? Yes.
And log 2 or log?
Yeah, LZN, right? So every time it is making 2. Okay, we can say log base 2, log of with base 2 n times, right?
Yeah.
For instance, for a number, if we have n here, we have n, if n equal to 1000, we may need only 10 split, right? Height will be 10, right? We see that log LZN for n equal to 1000, it is 10, approximately 10, right? It will take only 10 times, 10 splitting. After 10 splitting, we will come up with some small unit that will be easy to solve, right? So then this length is LGN. You understand why this is LGN? Because how many times it will be splitting? Okay, it's not n by 2. Okay, so every time it is splitting on n by 2, and then every time it is splitting again n by 2, then ultimate split will be LZ, that means with base 2 n times. Okay, and then so then total time will be, you see this, so this one will take n times, cn times, and this one will take 2 times cn by 2, then it will take cn. This one will take cn, like there are 4 cn by 4, right? So multiply, then it will get cn, and every time so you will get cn times. So then if you sum up this, okay, then how many times it will be? So you will sum sorry. Okay. Okay. So how do we calculate the total time complexity over here? So let us make a rectangle like this. A rectangle, right? So if you draw a rectangle like this, okay. So this side is LGN, right? And this side is CN, right? The total will be, so rectangle, multiply it, then we will get, so this is, if we make a rectangle, total rectangle, right? So then we will get Cn times log n, LGN, then we will get Cn times LGN plus this part, right? Okay, this part is merging time. This part is taking the splitting times this is splitting times, recursively solving times, and the third part, this part, is taking merging time plus merging time is Cn. This total, this one. So this one is the Cn log n plus this is the Cn. Has anyone any questions so far? So in your class, please bring in your notebook, okay? You can pencil or pen and a notebook. We will give some activities, okay, sometime to practice. Anyone has any question? Okay. So later we will see that the master theorem when you go our next lecture next week, maybe we'll go, let me see, next week steps. Yes, next week we will learn master theorem, and we will come back to divide and conquer method again. Okay, so we will analyze, we will learn more how to analyze an algorithm. Okay, so this is the end of this chapter. Now I like to give you some homework to study. So go to like this chapter 3, okay, and try to read it. Asymptotic notation, that means assume that for a very large n that meets that infinite position. Okay, in that case, what will be the time complexity of an algorithm? If we understand that, then we will understand big O notation over here, that is for worst case. Okay, so in a test you will be writing this kind of definition. Okay, this is the definition of big O, that takes the time, how much time it takes for all worst case running time. And then if you understand this, then it's slightly opposite. Okay, this is big O notation definition, and then there is a small o notation, and there is a omega notation. Okay, so omega notation says that how much minimum times it takes. So at least it will take, your algorithm will take this much time. Okay, and then there is another notation is called theta notation. So there is small o notation, small omega notation, and there is one more thing is called theta notation, that is used if upper bound and lower bound has subcommon position, then we use that theta notation, or in case we use minimum amount of time if there is a common amount of time. So the homework will be try to understand this space, only this one. Okay, come up with this one from B first, understand the B first, this middle part, then C, then A. Okay, I will discuss this in lecture, but please spend some time, just one page, at least one or few pages, read, and then give focus here, and then try that if you understand this. Okay, not too much homework, but if you spend some time, it will be effective. Okay, okay, and next week we will have one quizzes, right? Quiz 0. The quiz 0 will be from mainly syllabus and my communication policy. So in case sometime if I want to give some bonus points, I will use this quiz. Okay, so until although I'm saying that it is non-graded, but I may use it as grading. Okay, that is it. Do you has anyone any question? Okay, so people get panic. So with algorithm analysis course, while students take algorithm analysis course, they feel very discomfortable. Okay, then they know this is hard course, but let us do together. Okay, let us study together. Then I know some techniques. I want to share my techniques to you. There is some complicated process when I studied, and then when I taught this course, I figure out some technique to remember some complex steps. I will share my techniques, and if you learn something new, some good technique, share with me. Okay, and in this way, let us make our journey collaboratively, so that at the end everybody becomes happy and successful, right? Okay. Okay, so has anyone any question? Okay, thank you everybody, and you have a good weekend.